Yeah, hello everyone. I believe you're all doing great. Um, this is a pre-recorded version of the continuation of where we left from last week. We began with trigonometry, and we are going to continue from where we left off. Um, Today is basically going to be um, question and answers. Yeah, we will probably touch some one or two concepts and then continue with solving of questions. So, before I continue, let's do a quick overview of what we've learned so far under trigonometry. Okay, all right, all right. So, let's do a quick revision of what we did the other time. So, we started with right angle triangle, and then we said that let's insert shapes. Okay, so let's give ourselves this. So probably this could be an isosceles triangle or an equilateral triangle. Then let's draw our right angle triangle over here. Okay. All right. So in our previous lecture, we said that uh, right angle triangles they have three parts. We have the hypotenuse, which is mostly the diagonal. Then we have the opposite, which is mostly vertical. Then we have the adjacent, which is mostly horizontal. So this is basically the structure of a right angle triangle. And we said that there is a formula we call the Pythagoras formula or the Pythagoras theorem, which states that so Pythagoras theory states that the square of the length of the hypotenuse is equal to the sum of the square of the opposite and the adjacent. And that is Pythagoras theorem. In other words, if we are to label our triangle A, B, C, Pythagoras theory mathematically defines that AC squared is equal to AB squared plus BC squared. So this was what we were able to establish the other time. And we solved quite a number of problems with this formula. So let's do a quick revision and solve one problem before we continue. So for instance, we have say a triangle like this. We have a triangle like this. We have x, z, and then y, and then we've been given here to be 5 centimeters, and we've been given here to be 3 centimeters, 3 centimeters, and then we are asked to find this side. So find line xz in the diagram above. So we are going to use Pythagoras theorem to simplify this one. So generally the theory states that what the square is y of the hypotenuse is equal to the sum of the square of what of the opposite and the adjacent. But here lies the case, we already have our hypotenuse, so we have to find our opposites. So the missing value here is the opposite. So it means we are going to find the value of what xz. So xz squared will give us what xy squared minus what zy squared. In other words, xz squared will give us what 5 squared minus 3 squared. What are we going to get? Xz squared equals to 25 minus 9. Xz squared is equal to what? 16. Xz equal to 4 centimeters. So it means we have 4 centimeters here. We have 4 centimeters here. Okay. So that was what we did the other time. There's one example of what we did the other time. And we also talked about Pythagoras triples. We said there are mostly 3 values that fit into the Pythagoras theorem. 3 pair of figures that fit into the Pythagoras theorem. So we said examples of the triples we have. So we talked about Pythagoras triples. And we said examples of the triples we have. We have three. We have three, 4, 5. This is first set. We can also have 5, 12, 13. Second set. So these are basically whole numbers. These are whole numbers. And then we can also have 8, 15, 17. And then we can also have 7, 24, 25. Then we can also have 15, 36, 39. We can also have what 9, 40, 41. And I said the other time that when you take every Pythagoras triple, the largest value is the hypotenuse. The largest value is the hypotenuse. And the first two, they could be the opposite or the adjacent. The other time I mentioned they are what? They are commutative, right? I believe you know commutative properties. Yeah. So let's say addition and multiplication, we know they are commutative. So let's say A plus B the same as B plus A, right? And then A times B is the same as B times A. So this is the commutative property of addition and multiplication. So in the same way, when I square this one and I square this one, it will still give me the same sum in the reverse form. Okay, so the longest side is the what? Is the hypotenuse. So the 13 is our hypotenuse, 25 is our hypotenuse, 40 is our hypotenuse, our hypotenuse, our hypotenuse. These two, they could either be the opposite or the adjacent, right? But what you have to take notice of is that the 5 or the 17, the 39, the highest value is always the what? Is always the hypotenuse. Okay, so you should take notice of that. The highest value is always the hypotenuse. So this also means that when I square the first one and I square the second one, then I find the root of the sum, I should get 5. So for instance, let's take the first triple. The first triple, we have 3, 4, and then 5. When I square 3 and I add it to the square of 4, the answer I will get, the square root of the answer I will get should be 5. So this one will give us what? This one will give us 9 plus what? Plus 16, which will give us 25. Now the square root of 25 is what? It's 5. When we take the second triple too, it's the same formula that it uses. So we have 5, 12, 13. When I square 5 and I add it to the square of 12, the answer I will get should be the square root of the answer I will get should be 13. So let's see, 25 plus 144. What is it going to be? 25 plus 144. So 25, 14, 144, 25. We have here 9, 6, 1, 169. We have 169 over here. Now the square root of 169 is 30. So that is how the triple works. So if you're able to understand the triples very well, you will not suffer in your objectives, especially when you're asked to find either the hypotenuse or the opposite, or even the adjacent. Okay. Then we went ahead to solve some complex questions. Yeah, there were some questions that, for instance, in this particular question, it used what? An equilateral triangle. There was this question that made use of an equilateral triangle. So let's or probably an isosceles here, it depends. So let's say this. Okay, let's give ourselves this beautiful triangle here. Let's divide our triangle into two. Okay, so we've divided our triangle into two, and now this is the preamble of the question. In the diagram below, calculate the length QR in the triangle PQR. So we have P, we have Q, we have R, then we have N. We have here to be 13 centimeters, we have here to be 12 centimeters, and we have here to be 15 centimeters. Now watch how I'm going to solve this. So our mission is to find the length of QR. So QR is this distance from here up to this side. And we know that QR consists of what? The sum of QN and NR. So when I add the length of NR plus what? Plus QN plus NR will give me what? QR. So this should be noted down. Okay. So let's see how we are going to solve this question. All right. So first of all, we are going to find Qn. So we will write solution. Solution. We write what? Qn, line Qn plus line what? Nr will give us what? Line Qr. Then we will find our Nr. We will find our Qn first and then Nr. Now looking at this diagram, the Qn is our what? Our adjacent. And in order for us to find Qn, how are we going to find Qn? So Qn squared will be equal to QP squared minus Pn squared. So Qn squared will be equal to QP is what? 13. So 13 squared minus 12 squared. So what are we going to get? Qn squared equal to 169 minus 144. So let's do a 169, 144. This one will give us what? 5. This one will give us 2. So 25. So we have 25 here. Qn squared. To eliminate the square, what do? We square root both sides. So our Qn will give us what? Square root of 25 is what? It's 5 centimeters. So now we have our Qn to be what? To be 5 centimeters. Now let's come to Nr. Let's come to Nr. So for Nr, we are going to apply this a similar formula to also get the Nr. So PR squared. So we know that Nr squared will be equal to PR squared minus, I believe you know at this point you should know why it's minus. So we use the Pythagorean theorem, then we did change of subjects in order for us to get what? To get our Nr. PR squared minus what? Pn squared. Which is going to give us what? So we have Nr squared will be equal to 15 squared minus 12 squared. 255 minus 144. So Nr squared, still Nr squared equals to this. So we have Nr squared will give us what? 225. So let's do 225, 144. This will give us 1. We will borrow 1, we get 12. So we'll get what? 8 over here. So we get 81. Square root of 81, square root of 81. Nr will give us what? 9. So here becomes 9 centimeters. So now we have both Nr. Now we have both Qn and then Nr. So line centimeters. Make sure you bring the line. Okay. So we can say that therefore line QR will be equal to what? 5 centimeters plus 9 centimeters, which is going to give us 14 centimeters. So that would be our answer. Okay. Then that wasn't the only tough question we encountered. There's this question, so I don't think we tackled this very question I'm about to solve now. So let's try and see if we can also solve this one too. This same case, they brought an equilateral triangle like this. And look at what they did this time around. They divided the triangle as usual. Then they labeled here A, B, and C. They gave here 5 centimeters. So this way you can tell us this is an isosceles triangle, right? Two sides are equal. 5 centimeters, 5 centimeters. Then they give the whole of AC to be what? To be 8 centimeters. And now they are asking us to find, so let's label here D, BD. So this is the preamble of the question. In triangle ABC below, AB equals BC equals 5 centimeters and AC equals 8 centimeters. Find BD. So now, if the whole of this one is 8 centimeters, what do you think BD will be? Look at this very one. From here to here is 8 centimeters, and this one has been divided equally. This tells us that AD is what? Is 4 centimeters. This particular side is 4 centimeters. So, and this also is also what? Is also 4 centimeters. Okay. So how do you solve this? So solution. So using the Pythagoras theorem, so we can use say from the angle what? From the triangle ABD. And I know when I talk about ABD, this is ABD. This is ABD. This is the ABD triangle I'm trying to talk about. The ABD triangle. So from triangle ABD, AB squared is equal to what? Is equal to AD squared minus BD squared. Sorry, plus BD squared. BD squared. The hypotenuse squared, using the Pythagorean theorem, hypotenuse squared is equal to the sum of the adjacent squared and the what? And the opposite squared. So, but our AD, which is the 4 centimeters we had here, will be equal to half of what? Of AC. When I say half of AC, I believe you get it. This is AC. From here to here is AC. Half of AC will give you 4 centimeters. So now we can say in our solving that half of what? Of 8, which is going to give us what? 4 centimeters. So we know AD is what? Is 4 centimeters. So with the knowledge of knowing that AD is 4 centimeters, how are you going to find the value of BD? Remember, we are looking for BD. So now our BD squared from this main formula will be equal to what? AB squared minus AD squared. And what is AB? AB is 5 centimeters. So BD squared is equal to 5 squared minus 4 squared. What are we going to get? BD will give us what? 25 minus 16. What are we going to get? 9 squared. BD squared. So square root of 9 is what? Is 3 centimeters. So BD is 3 centimeters. So I'll come and place my 3 centimeters here, and I'll be done. So that is the value of what? Of BD. Now, if you know the Pythagoras triple very, very well, the moment you see 3, 5, and 4, you definitely know that the answer is 3. Yeah. But if it's subjective, you have to solve to get your answer. You have to follow the rules to get your answer. Okay. Now, this and many other things we did in our previous lecture. What we just did was just a revision. Now let's take this question. Let's begin with this question. I think this is a very nice question, examinable. It can come in your BECE likely question. So let's solve. So we have a right angle triangle. This one they don't really. Okay, let me see. Right angle triangle. Okay, let me use this one. Let's use our lines. So let's solve this question. Okay. Okay, so we have a right angle triangle here, and okay. So this is the preamble. In the quadrilateral, I believe when we say quadrilateral, you know what it is. Quadrilateral is a four-sided figure. A, B, C, D. So A, B, C, D. Below, AB equals 3 centimeters. BC equals 4 centimeters. CD equals 12 centimeters. And angle ABC equals 90 degrees. And angle ACD is also equal to 90 degrees. Now, your question. Calculate I, the perimeter of ABCD. II the area of ABCD. ABCD. Okay, so this is a likely examinable question because the question is very, very, very complex, and it's a combination of different topics. So we have plane geometry one inside. We have right angle triangle inside. We also have the area of solid figures, area and perimeter of solid figures, two inside. So here is 90 and here is 90. So now when you are given a question like this, it's up to you to know where hypotenuse is, where opposite is, where adjacent is for all the triangles. Now we know that we have two triangles here. The first triangle is what? ADC. And I always tell you, the moment you see where the 90-degree is, you should know where your hypotenuse is, you should know where your opposite is. So at this particular triangle, this one, the triangle ACD, we know that this is our hypotenuse, this is our opposite, and this is our adjacent. Now, when we take this triangle ABC, obviously this is our opposite, this is our what? This is our adjacent, and this is our what? Our hypotenuse. Okay. So now the question is to find the perimeter. Now, in order for us to find the perimeter, what do we have to find? We have to find perimeter simply means the distance around what? The plane figure. So first of all, solution. So so the perimeter will be equal to what? AD. So line AD, which is this one from here to here, plus from here to here, DC plus from here to here, CB plus from here to here. So all the exterior length AB. But looking at the diagram, we don't know what AD is. We don't know what AD is. Do you get the point? Because there's no value here for us to use. So in order for us to find our perimeter, we first have to find our what? Our AD. But how can we find our AD if we've not found our this line AC? Because once we get line AC, we can use line AC to find what? Line AD. So what do we do first? We apply Pythagorean theorem to find what? To find line AC first. So we can go ahead and say by Pythagorean theorem, what? AC squared will be equal to what? AB squared plus BC squared. So now we are finding AC, so that AC will help us find what? AD. Good. So AC squared will give us what? AB squared, 3 squared plus what? Plus 4 squared. What are we going to get? 9 plus 16 AC squared. 9 plus 16, which is going to give us what? I'm continuing from here. So 9 plus 16, so AC squared will give us what? 25. No, square root of 25 is what? AC will give us what? 5 centimeters. So now we have our AC 5 centimeters. It means our this side will becomes what? Becomes our 5 centimeters. Now, again, using Pythagoras theorem, so line AC, So now we have here to be 5 centimeters. So taking triangle ADC into consideration, we are to find what? AD. So again, using Pythagoras theorem, AD, which is our hypotenuse, equal to what? AC squared plus DC squared. AD, what's our AD? We don't know. AD squared equal to, what's our AC? Our AC is 5 squared plus, what's our DC? 12 squared, right? So our AD squared will give us what? 25 plus 1, 4, 4. What is it going to be? AD squared is equal to 169. Square root of 169 is what? It's 13. So AD becomes what? 13. So our line AD now becomes 13 centimeters. So now we can put 13 centimeters what? Here. So it's still the question I we are solving. So now that we have our 13 centimeters, we can now go ahead to do our perimeter. So our perimeter, which is equal to what? Line AD plus line DC plus line CB plus line AB. So now we have, looking at our diagram, what do we have for AD? So AD is what? It's 13 centimeters. So now we have 13. So 13 centimeters plus, I think DC is 12 centimeters plus 12 centimeters plus CB or BC is what? 4 centimeters plus AB. So AB is what? 3 centimeters. And this is simple addition. 13 plus 12 will give us what? Will give us 25. 25 plus 4 will give us 29. 29 plus 3 will give us 32. So we have our perimeter to be 32 centimeters. That's our perimeter. Now, our perimeter is now 32 centimeters. Now the next question is for us to find what? The area. So question II. So this could be a full question in BC. Find the what? We should find the area, right? Now let's see if we can copy our triangle and bring it over here. Let's see if we can let's see if we can copy. Let's copy our triangle. Copy. And then bring it here. Okay. Let's copy our triangle and then bring it here. Good. Now the question is to find the area now of the quadrilateral ABCD. So we are finding the area of this whole figure. But how can we find the area? Now remember that this whole thing is a combination of two triangles. So this whole figure is the combination of two triangles. So the first triangle we have is what? Is triangle ADC. The second triangle we have is triangle ABC. So how are we going to find the area? We first find the area of this triangle ADC by using half the base times the height formula. Then we are going to find the area of this same one, half the base times the height formula. Then we combine the area. So area of ABCD will be equal to the area of triangle ADC plus the area of triangle ABC. So first of all, let's find the area of triangle ABC. So you state this one, and then you let the examiner know that the area of triangle ABCD is equal to the area of triangle ADC plus the area of triangle ABC. ADC plus the area of triangle ABC. So first of all, we'll find the area of triangle ADC. So area of triangle ADC, which is ADC, is equal to half the base. What's the base? 5 centimeters times the height. What's the height? The height becomes the opposite, times 12. Now 2 centimeters. 2 will go into itself. 1 to go into 12. How many times? 6. 5 is 30. So now area of triangle ADC is equal to what? 30 centimeters. Remember, it's area, so centimeters squared. Then we come our second area. Area of triangle what? ABC is equal to what? Half the base times the height. And what is the base? The base is 3 centimeters. So half times 3 times what's the height? 4 centimeters. 2 going to itself 1. To go into 4 how many times? 2. So we have 3 times 2, which will give us what? 6 centimeters squared. So now the area of ABCD will give us 30 centimeters squared plus 6 centimeters squared, which will give us a total of what? 36 centimeters squared. So now in this question, we're able to solve for the perimeter, and then we're able to solve for the what? For the area as well. Now let's continue with this question. So today we'll be solving a lot of questions. So look at this question. The length of a side of an equilateral triangle is 10 centimeters. Find I, the height of the triangle. I, the area of the triangle. I, the perimeter of the triangle. So in this question, they did not draw any diagram. You have to figure everything out yourself. So how do you do that? First of all, you have to read the question and know the meaning of every single word. So the length of the side of an equilateral. So you should know what equilateral triangle is. It's 10 centimeters. So the question is, what is an equilateral triangle? An equilateral triangle is a type of triangle that has all its sides to be equal. So we take this. So let's see how we are going to solve this. So first of all, we give a diagrammatic representation of the question and see how we can solve it. So it says that what? equilateral triangle has one side to be 10 centimeters. And since you know equilateral triangle has all the sides to be equal, if one side is 10 centimeters, it means the other sides are also what, 10 centimeters, including this side, 10 centimeters. So the question is, we should find the height. Now in every triangle, the opposite is always the height. Take notice of this. In every triangle, the opposite is always the height. Take notice of this. So what do we do? This is our height. Good. And since it's an equilateral triangle, the moment we divide here exactly into two, here will become 5 centimeters, and here too will become what? 5 centimeters. I believe you get the point. Here becomes 5 centimeters, here becomes 5 centimeters. So now what will be left here is the height. So let's give this triangle, for the triangle, let's give it ABC, right? A, 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 B, C. This side and this side and this side, they are all equal because they are what? Equilateral triangle. So this now becomes our figure. So the first question is for us to find the height. In other words, for us to find the what? The opposite. So you still using Pythagoras theorem, we can find the opposite. How do we do that? So we can take solution. Considering triangle A, so let's give here D, this point. A, C, D, and using Pythagoras theorem, so we can decide to state the Pythagoras theorem directly or do the change of subject and state it. So let's state it directly and then do the change of subject. AC squared equals what? AD squared plus what? CD squared. So now what are we looking for? CD, right? That is our opposite. So now our CD squared will equal to what? AC squared minus AD squared. So what is our AC? 10 squared, right? Plus this one becomes our 5 squared. We are going to get 100 plus 25. Sorry, minus. Where's my eraser? Let me just reverse, reverse. Okay, minus 5, there's minus here, so minus 5 squared. We're going to get 100 minus 25, which is going to give us what? 75. So this is still our CD squared. We're going to get what? 75 CD squared. In order to get this one, we are going to get square root of what? CD equals, line CD is equal to the root of 75. Now, 75 is not what do we call it? A perfect number or a perfect square. When we say perfect square or a perfect number, these are numbers that we can find square root of them. For instance, we take 9, square root of 9 is 3. We get a whole number, right? We take 16, square root of 16 is 4, a whole number. We take what? 25, we get 5. We take what? 36, we get 6, right? We take 49, we get 7. So these are all perfect squares that when we find the square root, we get a whole number. But there are some numbers that we do not get their whole numbers. I believe you guys have started learning sets. It's part of your new curriculum. You've started learning sets. I guess so. Yeah. So you realize that the root of 75 is going to give you what? So this one is going to give you 8.66. Now someone will ask, how did you get the 8.66? Now it's simple. You just have to use calculator. You just have to use calculator to get your 8.66. Yeah, to get your 8.66. Okay. If you want us to break it down into set 2, yeah, we can do that. But still, you just have to arrive at what? At a number, a complete figure. That is 8.66 centimeters. So you have to know that here becomes what? Root of 75. So here becomes root of 75, or better still, 8.66. So 8.66, or root of 75. So here becomes 8.66. Okay. So now we found the what? We found the the height. So the question also told us to find what? Found the height. The question also told us to find the area of the triangle. So now that we found the height, we can find the area. So simple. So what is the area of a triangle? Half base times height, right? So area of triangle triangle ABC. ABC equal to half the base. Right? Here, where is the base? The base now becomes our AB. Our AB times the height. Our height becomes what? Our height becomes our CD, which we've already found. So now we get half the base, which is 10 centimeters, times 8.66. This one, 2 going to 5 how many times? 2, 10 how many times? 5. So we're going to get 5 times 8.66. And what are we going to get? We are going to get 43.3 centimeters squared. How did we get the 43 times 3? Now it's simple. This is a decimal which is multiplying the whole number. So what do you have to do? When I give me the question like this, a decimal is multiplying the whole number. So first of all, we move this 1, 2, and we know that we've already moved forward 2 what? From the decimal point, we've moved forward twice. So we are going to get 866 by what? 5. Now let's simplify this and see. 5 6 30 0 remainder 3. 5 6 30 plus 3 33 3 remainder 3. 5 8 40 plus 3 43. Right? So how many decimal places did we move when we stood at this point? 2. So we stand at the back and bring back the 2 decimal places we moved. 1, 2. Now we have our 43.30 centimeters, which is the same as 43 times 3 squared. So that was how come we had our 43 times 3. So this is just by the way, in case you get like anytime you get a decimal multiplying the whole number, this is the same thing you are going to do. Anytime you get a decimal multiplied by a whole number, first of all you are going to move the decimals and then make it a whole number. Then after you are done solving or do your multiplication, you bring the decimals back to arrive at your point, your decimal point. Yeah. All right. So that will be our area. So what's the next question? Our next question is to find the perimeter. So perimeter, we are talking about AC. We are talking about what? Our line AC, which is 10 centimeters, plus our line AB, which is 10 centimeters, plus our line CD, which is what? 10 centimeters. So it's so simple. So perimeter is equal to what? So the perimeter will equal to what? 10 plus 10 plus 10, which is 30. So perimeter will equal to AC plus AB plus C, 10 centimeters plus 10 centimeters plus 10 centimeters equal to 30 centimeters. We are done. Okay. Now, let's take a look at this angle of elevation and angle of depression. And these questions sometimes confuses students a lot. And mostly we are not going to deal with those that involve the angles, especially you guys are not given the chance to use calculators. Or probably we will be using a table. I don't know whether you'll be provided that table during the examination. There are some tables that have constants that you use to solve your questions. And at your level, yeah, I don't think they will give you that, you know, regarding angles. Because those ones, definitely you have to use the calculator too. Like the, like the tan, the cos, sine, you have to use calculators together. Or they will give you a table or a chart that has, fundamental constants that you would refer to when you are solving your work. Okay, so let's try and solve one of these questions. So it's under the tangent of an acute angle. Okay, so let's continue. Alright, so we are going to solve some word problems, a couple of them. Okay, so let's solve some objective tests. I think we have like 3 objective tests here. Then we'll solve some subjectives and we'll see how far we'll go. So word problems. And objectives. Word problems and objectives. Okay. So the first. Okay, so let's deal with the objectives first. OBJ. So question 1. Calculate the length of QR in the triangle PQR. So this is triangle PQR we have over here. PQR. QR, 13 centimeters here, 12 centimeters here, 15 centimeters here. And they are telling us to find the length of QR, which is from here to here. And they labeled here, oops. And they labeled here N, and we have 13 centimeters, we have 12 centimeters, we have 15 centimeters. They labeled here, and they say we should find the angle QR. And possible answers: A, we have 11, B, we have 14, C, we have 16, and D, we have 17. So how do we solve this question? So this is objectives. Objectives should be very, very fast. So if you know your triples, you should know what QN is, and you should know what QR is. So if you are very, very fast and you know your triples, you know your Pythagoras triples. So let's consider the triangle PQN. Triangle PQN. So we have, triples. We have 5, 12, 13. So 5, 12, 13. You should know that this particular side is what? It's 5 centimeters. Then the other one, you've seen 12, you've seen 15. So if you really, really know your triples, you've seen 12, you've seen 15. What do you think will be your next? This one. So 12 squared. So we have 15 squared minus 12 squared. 225 minus 144. 225, 144. 181, right? So what do we have here? Okay, so 10, 12, 81. So we have 9. Square root of 81 is 9. So we have 9 here. Then you should know that this 5 centimeters plus 9 centimeters will give you 14 centimeters. So the option B, I think the option B was 14 centimeters. Yeah. So the answer is B, 14 centimeters. So you just have to be quick. It's objective, so you just have to be quick. Question 2. Question 2. Which of the following dimensions of a triangle form the sides of a right angle triangle? So this one is definitely talking about triples. So we have 3, 4, 3 centimeters, 4 centimeters, 6 centimeters. B, 3 centimeters, 5 centimeters, 7 centimeters. C, 3 centimeters, 13 centimeters. Sorry. C, we have 5 centimeters, 13 centimeters, 17 centimeters. Then D, we have 5 centimeters, 12 centimeters, and 13 centimeters. Now the answer is obviously D, if you know your triples very well. So when I square this and I square this and I add them, the answer will not be the square root of the answer will not be what? 6. When I square this, add them, the square root of the answer will not be 7. But when I square this, let's take d. 5 squared plus 12 squared, 25 plus 144, 169. Square root of 169 is what? It's 13 centimeters. We have 13 centimeters here. So the answer for this particular question is what? Is D. So this is the perfect triple that fits into the Pythagorean theory, hence follows the dimension of a right angle triangle. Okay. Question 3. Our third objective. So question 3. We have this triangle here. This is K. This is K. K over here. We have 62 degrees here, and then we have here. The question is, we should find angle. So let's name here J. Let's name here M. Find angle K M J. So this is pretty simple. So this one, this is more like angles. You know, the total angle of a triangle is what? The total angle of a triangle is what? Is 180 degrees. And we have here to be 90 degrees already. But we don't know what this one is. So simply 62 degrees plus 90 degrees plus angle KMG equals to 180. Angle KMG equal to 180 minus 62 plus 90 will give you what? This one will give you 152, I guess so. 152. Angle KMG equal to what? 152. So 180 minus 152 will give us what? We borrow 1 from here, 10. 10 minus 2 will give us what? 8. Now we have 7 here. This will be 2. This will be 0. So 28 degrees. So we have here to be what? 28 degrees. And of course, the objectives we had A, 28 degree, B, 62 degrees, C, 90 degrees, D, 118 degrees. So the answer is obviously 28 D, 118 degrees. So that brings an end to our objectives. That brings an end to our objectives. That brings an end to our objective. So let's solve some 1 or 2 word problems. Okay, so word problems. Word problems. So the foot of a ladder is 2 meters from a wall, and the top of the ladder is 6 meters. above, some will say above the ground. Calculate the length of the ladder. Okay, so solution. So first of all, in order for you to get understanding, you have to do a diagrammatic representation of your work so that it gives you clarity. It opens your mind, it opens your eyes. Alright, so the foot of a ladder from a wall. So we will draw our wall. So this becomes our wall. So this is our wall. The foot of a ladder from a wall, and the top of the ladder is, so let's say the foot of a ladder is 2 centimeters, 2 meters from a wall. So this is our ladder. This is our ladder. So this is the foot of the ladder, and this is the wall. The distance between the foot of the ladder and the wall is what, 2 meters. This tells us that this becomes the adjacent, right? Good. The top of the ladder to the ground, and the top of the ladder is 6 meters above the what? The ground. So when we take the ground here to the top of the ladder is 6 meters. They say we should find the length of the ladder. It means the hypotenuse. So this is a very simple question. So we can label our ladder A, B, C. We can label our diagram, not our ladder. Our diagram, the ladder is AC. A, B, C. So how do we find our ladder? So length of ladder. So let length of ladder be what? AC. We are defining the length of the ladder as AC. So our AC squared, so using Pythagorean theorem, our AC squared will be equal to what? Our AB squared plus what? BC squared. Of course, we've done the diagrammatic representation, so the examiner will know what AC and AB is. So AC squared will give us AB squared, 6 squared, plus what? Plus 2 squared. What are we going to get? AC squared will give us what? 6 times 6, 36, plus what? Plus 4. 36 plus 4, what are we going to get? AC squared is equal to what? 40. AC will give us what? Root of 40. So here becomes root of 40. Now 40 is not what? A perfect number. So we cannot find, it's not a perfect square, so we cannot find the root of 40. Right? So we cannot find the root of 40. Okay. So you can punch directly on your calculator to get the value for the root of 40. Okay. Okay. So root of 40, I have it here to be 6. So AC will give us 6.324. So 6.32. So we have here, will become what? 6. Meters. Okay. Alright. Now let's take next question. Let's take our next question. So our next word problem. the height of an isosceles triangle is 6 centimeters. Find the third side if the length of the two sides of the two equal sides is 10 centimeters. So see the examiners, these are some of the questions they said. They want students to think, they want students to reason. So for the height of an isosceles triangle is 6 centimeters. Find the third side if the length of the two equal sides is 10 centimeters. So first of all, what you have to ask yourself is, what is an isosceles triangle? An isosceles triangle is a triangle that has two of its length to be equal, hence two of its angles to what? To also be equal. An isosceles triangle has only one line of symmetry. So let's take this one to be an isosceles triangle. And two of its sides are equal. And two of its angles are equal. So if two of its sides are equal, we are trying to say that this is 10 centimeters and this is also what? 10 centimeters. So the question is for us to find here the last side. So let's label here A, B, C. The question is for us to find the last side. So A, B, C, and they've given the height from here to here to be what? To be 6 centimeters. And the question is, we should find the third side. So AC is what we have to find. So now, what are we going to do? We are going to pick triangle ABC. Let's make it D, ABD. Right? And whatever we get here will be the same for this side. Whatever we get here will be the same for this side. Because they have the same hypotenuse, they have the same what? Opposite. So how are we going to find it? So quick, Pythagorean theorem. How are we going to find this side? So first of all, we have to find AD, right? So AD squared will be equal to what? AB squared minus BD squared. What are we going to get? AD squared will give you AB. What's AB? 10 squared. 10 squared is what? 100, right? Okay, so let me check. This side is 6 squared. Okay, 6 squared, yeah. 6 squared. This one is 10 squared minus BD. What is BD? BD is 6 squared. 6 squared. So we get 100 minus 36. AD squared. So AD squared will give you 100 minus 36. I borrow 1 from here. I borrow here from here. Here becomes 10. Here becomes 9. I subtract this one from this. I get 4. I subtract this one. I get 6. Right? 64. So here it means we are going to get a perfect square. 64. We know that AD will be equal to square root of 64 is 8. So we have here to be 8 centimeters. And we have here to also be what? 8 centimeters. They say we should find the third side. So the third side, which is what? Which is... So once you get to the 8 centimeters, you can say that AD equal to what? BC equal to 8 centimeters. You should define so that the examiner will know that this one too is 8 centimeters. So what is AC? AC will be equal to what? 8 centimeters plus 8 centimeters. line AC, line AC, line. Give us what? 8 plus 8, 16. 16 centimeters. So therefore, AC, which is the third side, is what? 16 centimeters. Isn't math beautiful? Yeah, it is. It is. It is what it is. Okay, so let's continue. So our next question. A rectangle. A rectangle. So these people, they are very tricky. Is 12 centimeters long. And 9 centimeters wide. Calculate the length of a diagonal. So pretty quick. You see rectangle. What are you going to do in order for you to get this one right? You draw a rectangle. A rectangle has what? Has 12 centimeters. So here 12 centimeters long, 9 centimeters what? Wide. Which means width. They say we should find what? They are diagonal. So how are you going to find they are diagonal? Simply means they are what? They are hypotenuse. So this tells us that when you take a rectangle and then you divide the rectangle diagonally, you are going to get two right angle triangles. So you can see. So the question asks us for us to find out the diagonals, which means this side. And you know that opposite sides of rectangles are equal, right? So if here is 9 centimeters, here too will be 9 centimeters. If here is 12 centimeters, here too will be 12 centimeters. Now let's label here A, B, C, D. So the length of the diagonal will be AD. So in order for us to get AD, so using Pythagoras theorem, AD squared will be equal to what? AB squared plus BD squared. AD squared will be equal to what is AB? AB is 9 squared plus what is BD? 12 squared. So we have AB squared equal to 9981 plus 144. So I always do the calculation here for you so that here becomes what? 5. Here becomes what? 12. 2, remember 1, 225. So we have AD squared equal to 225. What is the square root of 225? AD you give us what? 25. So we have 25 centimeters over here. So that is it. That is it. So our line AD, which is in 10 our diagonal, becomes 25 centimeters. Remember to bring your centimeters. So after you are done this one, you can go forward and tell the examiner that therefore the diagonal is 25 centimeters long. And that'll be it. Let's try our last question. So our last question. A ladder leans against a vertical wall of height 50 15 meters. This one, so we are asked to find the length of the ladder. Okay, so this one is basically the same thing. So let me just ignore, and let's try another one. So after I'm done, I'm gonna send you guys some question. I think it will be in the comment section. So it will just lead you to some Google Docs that contain questions of a similar kind. Then you solve, give me the answers. Okay, so we have, let's take a look at this question. Good. Question 16. I think this one is good. A ladder is 25 meters long. The foot of the ladder is 7 meters away from the base of the wall. How far up the wall is the top of the ladder? See questions like this. First thing, you make a what diagrammatic representation. So the ladder is, so a wall and then a ladder. This is our wall. Please, I'm not saying go and draw this wall, this long wall. We can just make a straight line. And then there's our wall, and then our ladder. Our ladder is 25 meters long. The foot of the ladder is 7 meters away from the base of the wall. This is the base of the wall, and this is the foot of the ladder. They are telling us that they are 7 meters away, which means the distance apart is 7 meters. So the question is to find what? The height of the wall. In other words, how far up the wall is to the top of the ladder. So in our terms, we are going to find the opposite. It's the opposite that we are asked to find. So we can label this one A, B, C, and then use it to solve our problem. So AB squared, by now you should know this already. AC squared minus what? Minus BC squared. So AB squared, what's AB squared? AB squared is what? It's what we don't know. What's our AC squared? 25 squared minus, what is our BC squared? 7 squared. 7 squared. You can forget these things, the line. So what are we going to get? 25 squared. Wow, that will be huge. 25 squared, which means 25 by 25. So let's do it. 5 5 25 5. 5 5 25 5. Remember 2. 5 2 10 plus 2 12. 5 2 10 0. Remember 1. 2 2 4 plus 1 5. 5 2 6 6 2 5. So we get 6 2 5 minus 7 7 49. So still AB squared. So now we have 625 minus 49. What is it going to be? So let's come back to the board. 625 minus 49. We borrow 1 from here to this side. It becomes 15. 9 plus 4 will give you 15. 9 plus 6. So we have 1. So we have 1 here. We borrow 1 from here. Here becomes 5. We borrow 1 from here to this side to make it 11. 11 plus what will give you what? 11 minus 4 will give you what? 4, 5, 6, 7, 8, 9, 10, 11. So I think 7. Then here becomes 5. So we have 5, 6, 7. So we have 5, 6, 7. Okay, so this is it. So we did a calculation. We have 5, 6, 7. So square root of 5, 6, 7 give us what? 5, 6, 7. Okay. So first of all, let's see. 6 to 5 minus 49. 5 is 576 rather 625. Oh yeah, so this is 5. So it's 576. 576 over here, as you can see from the solving we did here. 576. So square root of 576. Let's see what we get. Square root of 576. 24. So square root of 576, we are going to get what? 24. 24. So 24 centimeters. So this one is what? Square root of what? 5, 7, as we did here. 576, as we saw over here. Which is going to give us what? 27 centimeters. So 24 centimeters, sorry. So here becomes what? 24. In the question, it was meters that was used. So meters. 24 meters. Okay. Alright. So this becomes what? The length of our wall. Thank you very much for joining today's session. If you have any question, you can type it in the comment section. Then I'll attend to you. Have a wonderful day and goodbye.